Good afternoon, dear students. So far yesterday we have seen the Boyle's law. Today we are going to see the Charles law. Charles law. At a constant pressure is a constant, when a volume is directly proportional to the temperature. This is Charles law. At a constant pressure, volume is directly proportional to the temperature. What it means, sir? This is when a temperature increases, volume also increases. This is a Charles law. Okay. Then Kt or V by T equal to K. Same way, V1 by T1 equal to V2 by T2 and this is equal to. So it can be explained by Charles explained this experiment that you take 2 parts of water. 2 parts of water. Fill with water. This is cold water. This is hot water. You put the same size balloon. That's a balloon. When it is cold water, the same size balloon in the hot water, the balloon expands. The same balloon expands. Same balloon expands like this. What happens, sir? Here, temperature variation. Temperature increases. When the temperature increases, the balloon, inside the balloon gas, the air also expands. The random motion of the molecule inside it is getting too fast, then it expands. So that only we are having the enlarged balloon here. So this can be easily explained. When a temperature increases, volume also increases. Why? Because when a temperature increases, the gaseous particle inside the balloon get heated, then when the particles collide very fast, then the expansion takes place. That's why we are having the enlargement of the balloon. This is expounded by Charles. Okay. Then graphical representation for the Charles law. If we take plot a graph, temperatures versus volume, you can find this like this. For various pressure, this is for pressure. For pressure changes, then you can put like this. That is P1, P2, P3. Different pressure ranges, you can have a graph like this. Here, P1 is greater than, P2 is greater than P3. Then V by T versus graphical representation, V by T versus temperature. This is always constant. It's for a single pressure. If you have different type of pressure, then the graph will be like this. T1, T2, T3, V by T graph. Okay, these are the graphical representations of the Charles law. Then, we are plotting the graph between at a constant pressure. This is called isobar. Isobar. Constant pressure, volume versus temperature. And pressure is called a isobar. You can have a graph like this. See here. Temperature at x-axis, volume at y-axis. It's 0 degrees Celsius, 100, 200, 300, like this it goes on, minus 100, minus 200, minus 300, like this it goes on. Okay. Any graph plotted at a constant pressure, this is called isobar. Already we have seen in Boyle's law, that is isotherm. This is isobar. Okay. It may be initial volume, V0, initial volume here. If you take an increasing temperature, go like this. Okay, the graph goes like this. Thus, it is giving a straight line, the slope. So we can compare this to the straight line equation. You know very well what is the straight line equation. Y equal to mx plus c. This is straight line equation. Y equal to mx plus c. The same, this also giving a straight line. We can have a substitute this v equal to mt plus c. mt plus c. Here V is the volume, T is the temperature, M is a constant, C also is a constant. Okay. Initially at a temperature T equal to 0 degrees Celsius, the initial volume we can take as the initial volume V0. Initial volume V0. So at 0 degrees Celsius, you apply this condition to this formula, you are getting that V equal to V0. That is equal to m 0 degree Celsius plus C. So the V0 initial volume, that is equal to constant that you are getting here. Okay. Let it be equation 1. Let it be equation 2. Okay. V0 equal to C. Then the straight line, m value is slope. The slope value itself constant. The value is del V by del T. That is the slope value. You have this 3. Okay, keep it as a 3. Nothing but it is a straight line. So straight line equation you can have a y equal to mx plus c. The same way I am taking y instead of y, I am taking b. M for instead of x I am keeping t plus c. The same. V is the volume, T is the temperature, C is a constant, M is also is a constant. Then at the 0 degree Celsius, that is the initial temperature. The volume of the gas, initial volume, we can find as we can substitute in this equation, you get a V0 equal to C. And further, slope value is constant value del V by del T. What is called as del V and del T? Del V is a change in volume. Del T is nothing but a change in temperature. Change in volume and a change in temperature. Okay. Now you substitute 2 and 3. 2 and 3 in 1. Equation 1. Substitute 2 and 3 in a equation 1. You substitute 2 and 3 value in a equation 1. Okay. Then it will become V equal to del V by del T into T plus C equal to V0. This is equation number 4. This is equation number 4. Okay. Then what to do? Divide the equation 4. Divide the equation 4 by V0. By V0. If you divide the equation 4 by V0, you may get this V by V0. That is equal to 1 by V0. 1 by V0. Del V by del T at T plus V0 by V. Like this you are writing. Okay, you understand? Just I am dividing the equation 4 by V0. What happened here? The V0 by V0 is cancelled. Then you have an equation like this. V by V0 equal to 1 by V0 plus del V by del T into T plus 1. for getting equations like this. Okay, have the equation number 5. That is equation number 5. Then okay, Charles and GAY-LUSSAC'S all discussed together. They come to know that they introducing the term alpha equal to del V by del T. 1 by V naught. Alpha is nothing but a volume coefficient. Alpha is nothing but a volume coefficient. What is this? What it means, sir? There is when the temperature rises, there is a increase in volume. That is it mean. That volume coefficient can be given by like this. It is maybe you can have it is 6 alpha. That is volume coefficient 1 by V naught del V by del T. Now you substitute 6 in 5. 6 in 5. What is going to happen? V by V naught. Then that is equal to the total value. I can take as alpha into T plus 1. So it is equation like this. Alpha T plus 1. Then further you are expanding to the V equal to V naught alpha T plus 1. That is a final form. Equation number 7. This is the derivation for the Charles law. Mathematical derivation for the Charles law. Sir, what is the implying that, sir? It is nothing but now again you come to the graph here. When you extrapolating the graph, it goes to minus 273 degrees Celsius. It goes to minus 273 degrees Celsius. Okay, minus 273 degrees Celsius. This is at this particular temperature. So when you extrapolating the graph to x-axis at this particular temperature, that is minus 273 Kelvin, the volume will become 0. Volume of the any gases will become 0 at minus 273 Kelvin. So this is the after that temperature, the volume will be negative. That is impossible at all. Volume going to negative is impossible. At this particular temperature, for example, this particular temperature, you may have a negative value of volume. That is practically impossible. This is the graph. So new scale is founded before this. By explaining this, the new scale is founded. That is called a Kelvin scale. Kelvin scale and Celsius. Here 0 degrees Celsius, that is equal to 273.15 Kelvin. Okay. Minus 273.15 degrees Celsius, that is called 0 Kelvin. 0 Kelvin. There is 100 degrees Celsius, that is 373.15 Kelvin. This is called absolute zero. This minus 273.15 degrees Celsius or 0 Kelvin is called absolute zero. At that particular temperature, volume of any gases that is equal to 0. This is called absolute zero. So from this all the interpretation, Charles come to the conclusion that the volume expands while temperature increases. Volume expands, that in addition to the initial volume plus 1 by 273 of initial volume increases. This is a final statement. That's why we are giving volume equal to here. The volume equal to V naught alpha T plus alpha T is a volume coefficient, that is plus 1. Now it is very clear Let me explain with a imaginary explanation. I am having the volume V0 equal to 273 liter. This is imaginary value I am taking for your understanding purpose. I am taking V0 equal to 273 liter. Now, what is the change in the volume after temperature rises? V equal to, if you apply 273 plus 1 by 273 of V0 into, so V of T after time changes, V0 plus 1 by 273 of initial volume V0. This is the formula which we are going to use. V0 equal to 273, that is equal to 1 to 274. Okay, there is a final volume. How volume expands as 273 to 274. Okay, this is volume changes, volume expanded. So let us, we conclude that whenever temperature increases at constant pressure, volume expands by that initial volume 2 by 1 by 73. The V0 is initial volume. Whenever temperature rises to 1 degree Celsius, you may have the change in volume that 1 by 73 of V0. This is a Charles experimental verification. Once again, I may explain the derivation. You listen me properly. There is a straight line, is giving straight line. So straight line equation y equal to mx plus c I have taken. Then I am altering the straight line equation as per our law. V equal to mt plus c. Here V is a volume, T is a temperature, C and M are constant. Now at a temperature 0 degree Celsius, at initially 0 degree Celsius, I am applying 0 here instead of T. Then you are getting V0 equal to C, V0 that is equal to initial volume. V0 equal to initial volume. Then M equal to slope, straight line slope, that is constant, that is del V by del T. What is mean by del V? The change in volume. Del T is change in temperature, that is M value. Now I have 2 and 3 data, and these data is applied with the equation number 1. If I am applying the equation number 1, V equal to the M value del V by del T into T plus C equal to V0, that is equation number 4. For mathematical deriving purpose, I am dividing the equation 4 by V0. If I divide the equation by V0, V by V0 equal to 1 by V0 del V del T, T plus V0 by V0, then these are cancelled, you will get it like this equation. This is nothing but alpha. Alpha is volume coefficient that it can be given by 1 by V0 del V by del T. Then you are substituting alpha here, V by V0 alpha T plus 1. Then V equal to V0 alpha T plus 1. That's all. This is a mathematical derivation. Sir, this derivation what he is explaining. So what is the statement of Charles? Charles' statement is nothing but at a constant pressure, volume is directly proportional to the temperature. Okay, that's okay. How much it will the temperature mean? Volume increases when a temperature increases. For every degree rises in temperature, how much amount of volume will be increased? That is given by this formula. Okay, that is change in volume equal to the extended volume equal to V0 plus 1 by 273 by V0. This is how we are taking from it. This is graph. Extrapolating graph, it intersect at a x-axis, that is minus 273 degrees Celsius. That will be a absolute zero of this temperature. Any gases will have a zero volume. And after this temperature, the volume will be negative. It is impossible practically. So they come to the conclusion this like this. Okay. Let us do one problem later. At constant pressure 1 atmosphere, V1 equal to 0.3 decimeter cube, T1 equal to 200 Kelvin, V2 is we don't know, we need to find, T2 is given 300 Kelvin, V3 is 0.15 decimeter cube, T3 is what? So here if you see the data, there are two questions are asked. What need to be find? V2 value we need to find, then T3 value we need to find. So by looking this problem, what are the data are provided? V and T, volume and temperature is provided, the same value of constant pressure. So it is based on the Charles law that you need to find first, the solution, Charles law. So what is the formula, Charles law? V1 T1 that is equal to V2 T2 that is equal to V3 T3. This is the formula we have with us. So by using this formula, by applying this data, we are going to find the solution. First of all, we are going to find the V2. So V2, if I need V2, I can take this area, this formula. Okay, I am substituting this value 0.3 by 200 that is equal to, V2 is not known, so V2 I am keeping like this, but T2 is given 300. So from this we can calculate the V2. V2 equal to 0.3 into 300 by 200. Okay, then 1.5. 2 by 3, 1.5 you become 1.5 into 0.3. Then V2 value is will be 0.45. Okay, 0.45. So unit of 3 decimeter. Now we got a solution for a V2. Then we need to find the solution for a T3. So now what are the data we have? V2 is already found out 0.45. V2 is there. From this first solution we got it. T2 already is given in the question itself, 300. Okay. V3 is already given in the question, that is 1.5 decimeter cube, 0.15 decimeter cube. T3 is needed to find. Okay. Then, so we have formula V2 by T2 that is equal to V3 by D3 according to Charles, not constant. Now we substitute this data in your formula. 5 T2 300 that is equal to 0.15 divided by T3. So if you want T3, then you convert it like this: 0.15 into 300 by 0.5. Okay. Now you substitute this one 1 by 3, 100 Kelvin. T3 is 100 Kelvin. Got it, the answer? This is the way I have written data and working out. In a book, if you see, lot of theoretical part will be given. You read the theory properly and write the first given data. What are else given in the question, you write it. Then you find the law which is suitable for this data and apply it, and you got the answer. Okay. GAY-LUSSAC'S law. GAY-LUSSAC'S law. Okay. What is GAY? At a constant volume. At a volume is a constant. At constant volume, pressure is directly proportional to temperature. This is a GAY-LUSSAC'S law. At constant volume, pressure is directly proportional to the temperature. So it can be said as isotherm. If temperature is constant, Boyle's law, that is isotherm. Pressure is constant in a Charles law, that is isobar. Here volume is constant in a GAY-LUSSAC'S law, then it is a isochore. Okay. Then you are removing the proportionality constant by kT. Then P by T equal to K. Mathematical expression. Then a different type of pressure and temperature. P1 by T1 equal to P2 by T2. That is equal to K. Written like this. So volume is a constant. What are you saying, sir? Nothing but at a constant volume, when a temperature increases, pressure also increases. This is the logic. When a temperature increases, pressure also increases, or it is directly proportional to the pressure is directly proportional to the temperature. Okay. The graphical, if you want a graphical expression for the Gay-Lussac law, temperature versus pressure. So temperature increases, pressure also increases. The graph will be going like this for at a constant volume. For different volumes, if you take the graph like this, it will go. V1, V2, V3, V1 is greater than V2 is greater than V3. This is logic. Then the constant line for this temperature versus P by T graph, if we go with constant at a single pressure, at a single volume. We want to go that various volume if you taken, then this graph will be like this. P by T. It says that what it means, sir? It says that the P by T value always constant at any temperature. That's mean that P by T value is always constant at any temperature. This is about the Gay-Lussac law. Once again, I am repeating what is Gay-Lussac law. At a constant volume, pressure is directly proportional to the temperature. The mathematical expression, if we go, P equal to KT, K is a proportionality constant, a constant we can take, P by T equal to K. Then further expanding this equation, P1 by T1 equal to P2 by T2 equal to K. The graphical representation is there. Okay. Then let us move on to the Avogadro law. This is not a law, it is a hypothesis. What is the difference between the laws and hypothesis? Hypothesis is a statement without experiment. There is no scientific proof for that statement. That is called a hypothesis. Okay, but it may be right or wrong, it may be change or may not change. These are the oscillation. But it is hypothesis, it is assumption of the scientist. The Avogadro assumes that he is considering that this and so like this. That is called hypothesis. If it is law, it should be scientifically proved. That is called a law. So that always the Avogadro, we cannot say Avogadro law. It should be mentioned as Avogadro hypothesis. Hypothesis is imaginary statement or the statement which is not proved scientifically. It may go wrong or something else. So without scientific experiment, that is imaginary statement. That is called hypothesis. Okay, that's why I say Avogadro hypothesis. Equal volume of all gases. Equal volume of all gases will have an equal number of molecules. Equal number of molecules. What it means, sir? Equal volume of all gases, equal number of molecules. It's proved wrong later, but here there are some derivations are there. That's why I am explaining this. Equal volume of all gases at a constant temperature and pressure. This is condition. At a definite temperature and pressure, equal volume of all gases. Equal volume of all gases will have a equal number of molecules. What it means, sir? That means if 1 liter hydrogen, how many molecules? 1 liter hydrogen, there is some amount of molecules will be there. Maybe X. For same at a same temperature pressure, 1 liter of nitrogen also will have a X number of molecules. That it means equal volume of all gases will have a equal number of molecules. Okay. So it can be simply mathematically expressed like this. N is directly proportional to 1. N is number of mole volume. Okay. Or V is directly proportional to N. Then we can derive the expression V equal to K into N or V by N equal to K. Then V1 equal to V2 into so. Okay, let's see what is this. This is all about the Avogadro's hypothesis. Once again, I am explaining the Avogadro hypothesis, that is equal volume of all gases at a constant temperature pressure will have an equal number of molecules. That means number of moles that is directly proportional to the volume. Okay, that's all about the Avogadro. Today, so far we have seen that Charles law, GAY-LUSSAC'S law and Avogadro hypothesis. That's all about the Gay's laws. Already yesterday we have seen Boyle's law. Today all those three laws, Charles law, GAY-LUSSAC'S law and Avogadro law. Tomorrow we are going to see about the ideal gas equation. Thank you.